Hi, we're at the summit of Mount Diablo in Concord, California. People from all over the world come here to go hiking, picnicking, and enjoy the beautiful views. But we're here today to do some carpool chemistry. Today, we're going to show you how to draw Lewis structures for polyatomic ions. Let's take a look at the acetate ion. This is a group of atoms, 3 hydrogens, 2 carbons, and 2 oxygens that as a group has a -1 charge. As we know, that means it gained an extra electron somewhere along the way. We're going to find the Lewis structure for this. Well, we start off by listing the possible skeleton structures. How could these atoms be linked together with bonds? Well, there's many possibilities. You can go, the simplest possibility is a straight line, H, 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 C, C, O, O. Or you can mix and match it, H, C, H, C, H, O, O. And you could go on and on and on, and it would take you forever because there's so many permutations and combinations that you could do with this. However, if you take a look at some of the guidelines that we talked about, we see that, once again, sometimes more than one arrangement is possible. Hydrogen wants to form only one covalent bond. It's stable with 2 electrons. So hydrogen does not want to be inside the middle because then it would have 2 covalent bonds. It wants to be at one of the ends. Carbon wants to typically form 4 bonds with no unshared pairs. It wants to be in the middle. And oxygen wants to bond to an atom that is in the middle. It wants to bond to a central nonmetal atom. So knowing that, let's go ahead and place carbon in the middle first. Carbon linked up to another carbon. So we have 2 carbons in the middle. We see 3 hydrogens over here on the left-hand side. So let's place those 3 hydrogens attached to carbon. And notice how hydrogens are on the ends. They only have 1 bond to it. And then we have these 2 oxygens on the other end. And let's go ahead and place those oxygens here and over here. Once again, oxygen wants to be bonded to a centrally located nonmetal atom. Then it says to arrange atoms as evenly and symmetrical as possible. Is this even and symmetrical? Can we fold it along a line that's going down the middle and fold it on itself and have it match up? It looks like that fits the bill too. Okay? And now, because it's a polyatomic ion, make sure we put a big bracket around it. And we put that -1 charge there, noting that it gained 1 extra electron. Do we have enough electrons to make this happen? We know that electrons are the pieces of glue that hold this together. And the electrons that we look at are the outside valence electrons. Do we have enough of these to make this work, or might we need some double bonds inside there to make it work? To find out, let's make our electron tabulation. And we could even write down valence electron tabulation to remind us that we're looking only at those electrons in the outer energy level. Let's take a look at hydrogen first of all. Hydrogen, there are 3 atoms of hydrogen times, and from our periodic table here, we see that hydrogen has 1 electron in its outer energy level. 1 valence electron is equal to 3. Let's take a look at carbon. There's 2 atoms times, and carbon has 4 valence electrons. So 4 valence electrons is equal to 8. And then oxygen, we have 2 of them, 2 atoms times, and oxygen, we have 6 valence electrons. 6 valence electrons is equal to 12. So the total number of valence electrons in this structure are 11 plus 2 is 13. Carry the 1. 23 valence electrons. Okay, now we must take into account the fact that it somehow gained an extra electron along the way, perhaps from sodium who wants to give away an electron, or potassium. And so let's take that into account. -1 charge means that it gained an electron. Now don't memorize this, but think about what it means to have a -1 charge. It must have gained an extra electron, and that's how we add 1 electron there. So we have 24 electrons to work with. That is 24 pieces of glue holding this together. Is that enough? Well, let's find out. The next thing we need to take into account is the single bonds over here. We have 1, 2, 3, 4, 5, 6 single bonds. Single bonds. 6 bonds times 2 electrons per bond. And that means you're using up 12 electrons to form those single bonds. And 4 minus 2 is 2, and 2 minus 1 is 1. So we have 12 electrons left to hold this together. Well, let's take a look and see what else we have over here. Hydrogen. Does hydrogen need any more electrons to be stable? No, it doesn't. Neither does this, neither does this. How about oxygen? How many more electrons does this oxygen need in order to be stable? Well, it's got 2 from this bond. It wants to have a total of 8, so it needs 6 more. And do we have 6 in our stash of electrons down here to give to it? We sure do. So let's go ahead and place those 6 inside there. And we have -6 over here. 12 minus 6, we have 6 left over. And let's go ahead and take a look over here at this oxygen. This oxygen needs 6 more also. Do we have 6 left to give to it? Actually, let's back up. Let's fulfill this carbon first. We have 2, 4, 6. Carbon needs 4 more. Do we have 4 more to give to it? And it looks like we do. We have 6. So let's go, actually it needs 2 more. 2, 4, 6 needs 2 more. So 6 minus 2 is 4. 1, 2. And oxygen over here looks like it needs 6 more because there's 2 from here. But do we have 6 to give to it? It does not look like we do. We only have 4. And by the way, let's label this over here. These ones went to the oxygen. These ones went to the carbon. And these ones over here are going to go to the other oxygen. We only have 4 even though we need 6. And so what does this oxygen say to this carbon over here? This needs 2 more. This one's okay. But this oxygen will say, hey, can we share an electron with me? And carbon says, yes, I'll share with you. And that's fine, except for one thing, is that now carbon has 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons, 1 too many. Oxygen has 1, 2, 3, 4, 5, 6, 7 electrons, 1 too few. And so carbon says, hey, I have 1 too many. How about if I just give you 1 oxygen? And so we go ahead and reposition this electron from this carbon over to this oxygen over here. And now we have the Lewis structure for the polyatomic ion acetate. And if you want to be professional and clean this up, you can make it look nicer by going carbon, carbon, hydrogen, 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 oxygen, 1, 2, 3, 4, 5, 6, and oxygen. This is a double bond over here with 4 electrons, and we put our bracket around it and put our -1 charge there. And that's how you draw the Lewis structure for polyatomic ions. From the summit of Mount Diablo in Concord, California, This is Carpool Chemistry. Thanks for watching.